All right, welcome back, Calcsters. Today we get a new idea. And remember, we're doing the chain rule. So we're going to get into this. Now, as we're looking at these, our section 5.5, as we get cooking through here over the next week and a half or so, we are focusing on two main ideas. We're going to be looking at integrals still, but instead of the definite integrals with fundamental theorem, we're going to be covering what are known as indefinite integrals. Indefinite integrals. And the other part of this is U substitution. Now, I want to commend you guys, I think. I'm not sure if it's a positive or a negative, but we've used a lot of f of u's in here the last week or two, and nobody that I've noticed has made a joke that it sounds like anything else, which is the first time that's ever happened. So, well, it sounds like saying fu over and over, doesn't it? F of u all over and over. It keeps showing up. You're the first year that's never made that connection, which, like, we use u for everything, and we used f of u throughout I don't know. You guys just didn't make a rise out of it, which I'm cool with, but whatever. Okay, so check it out. We have a bunch of stuff to do in here. The very first thing, we're just going to jump in, and we're going to see that this idea, one of these at least, is not new truly. So we're going to start off with indefinite integrals. And I'm going to have a really short definition for this. The indefinite integral. Okay. When we think of an integral, if I just said the integral of f of x, does that sound normal to you? Is there any part of it's missing that we've been using like pretty consistently? Ooh, so with respect to x, maybe that's something that's missing, but if we find the area, do we need to know where the area exists? Ooh, we need the boundaries, right? The integral from a to b is how we normally talk about those things. But we've seen before that we don't have to think of the integral as just area, right? Like, it can express area and it's used for that, but it doesn't have to be just that. So if we're not finding area, maybe we don't even need those boundaries, right? Like, if we don't care where we're at and we just need like a function out of it, maybe the indefinite integral will exist and we'll use it. And this is just simply an integral without bounds. And I'm just going to say no bounds, which means there's no a and there's no b from which we run to and from. So super easy to define here. Piece of cake. If we want to take the indefinite integral of a function, f of x dx, without any bounds, do you have a gut feeling on what this ought to be? We've used a symbol without bounds before in a really kind of cheater way. How do you take the integral? What do you have to calculate? The antiderivative. And how do I write the antiderivative of f? Cap f. And then one more big part. There's one other thing that we haven't had to do lately because we've been doing indefinite integrals. What else do I need here? Plus c. Turns out that all the antiderivatives that we got in 4.8 are just indefinite integrals, and we just didn't use that language until today. Now, for this, we have a couple things to work out here. We have a new best friend, and I want you to make a note of this. I don't remember where our old best friend was, but we have a new one. New friend. I kind of like that F. It looks like a Disney F for some reason. Page 431. And I will show you your new friend. It's the exact same as what we had before, just a little bit nicer writing. So your new friend will be on page 431, and this is our new friend. Now, if you look back to the table that we had of antiderivatives, it's the exact same thing. All that we've changed is instead of calling it cap f of x, we're just using these integral symbols instead. Much more common. I would use this. This is your new best friend. Now, there's a few of these I would imagine that you guys probably don't have locked in right now. When do we want to do an antiderivative quiz? Or an indefinite integral quiz? Friday, after we get 4 more days of practice doing integrals, so that just by doing them, we get them hopefully locked in. Friday, after or before pi, one of those two things. We're going to plan for an antiderivative or integral quiz. Just basic rules. Cool. All right. Now, here's the cool thing. For a lot of these, we don't have any crazy ones to knock out. And if you guys want this table open, I would encourage it, page 431, because I'm not going to have it on the screen. But we're just going to jump in and do some indefinite integrals. And we should do these up on the board. Yeah, let's do board work. Now, from your perspective, because this is a very new thing for my teaching style, just so you guys know, and I think I love it, just so you know. The only part I don't like about it is the lack of stuff you have in your notes. The way that I've been doing it, saying write down the problems in your notes and work them in your notes if you'd like, has that been sufficient to keep your notes good? No major changes that I need to make then? Because if we work 3 problems on the board and none in your notes, later when you're doing the homework, you're going to be like, what the hell did I do? Because you don't have it written down. How about, I like that idea. How about I have you guys do 2 or 3 on the board, and then we'll do 1 more together as a class after the fact. That way you have a solid example. And obviously you can write down whatever you want in your notebook as well. If you want all these examples, write them all down. I'm cool with that. Sweet. Okay, so we'll get some problems written down quick, and I have 3 simple ones for you guys to work out with some indefinite integrals, and then we'll get our groups sorted out. An example. So let's do on A. I want us to take the integral, and I don't like that integral symbol. Okay, don't like that either. Still don't like it. Still don't like it. There we go. The integral, whatever. Let's do 3 easy ones. X to the 4th dx, and then on B, I will give you guys in a moment because we're going to do some groups and we're going to split them up. First one should be pretty chill, but let's get some groups worked out. So for these, I did not do any talking with these ones. You guys knocked these out like right away. First integral, no problem. Everybody had it like 30 seconds. Second one, a little harder to see, but as long as we remember that square roots, or any root for that matter, can be written as a rational exponent, then we're good with it. This one got people tripped up. Now, what I saw groups doing immediately is a natural thought. You're trying to do the integral of the top and the integral of the bottom, but let's think back to derivatives. If I had a derivative of a quotient, I didn't just do the derivative of the top and the bottom. The only time I ever did the derivative of the top and bottom separately is when we're using L'Hopital's rule. Only place we've ever done that. Otherwise, we had to sing a wonderful song. What's the song? Low D high minus high D low all over low squared. All right, awesome. Now, we do not have yet, and we won't in this class, a quotient rule for integrals. Quotient and product rules for integrals are the bad ones. We'll get to see a little tiny bit of it in introduction. Ultraviolet voodoo is what we'll see at the end of the year. Cool. All right. So as we're looking through these ones, or this one specifically, we are going to talk through this together. And I think most groups did fine with it. I don't know what color this other background's supposed to be, but it seems like it's fine. So I'm not sure what's going on up here. Weird. Okay. Your guys' first thoughts were reasonable, but after a little bit of a shove, what was the way that we could rewrite this integral? And notice I'm not going to get rid of the integral symbol until we actually do the integral, but love it. X cubed over x to the 4th minus 1 over x to the 4th. Okay, all we're doing is splitting up a fraction, right? We can do that as long as we have a single denominator. No issues. And then this one might be skipped on your actual work. What's the next line going to be? The integral of what? 1 over x minus 1 over x to the negative, sorry, x to the 4, or I might have just given it away. Is there a better way to write 1 over x to the 4th? X to the negative 4. Okay, at this point, notice we've not done an integral yet. Hence the symbols are still there. I think most groups added them in when I came around and encouraged people to add them. You have to include to show that you haven't done it yet. Just like we did with derivatives, just like we did with limits, we have to show it. Okay, once we're here, I'm going to do more work on the board right now than I would suggest you do on your own pages, but I want to make sure we can see where this is happening. If I just make this statement, everybody I think is going to be able to finish it. The integral of a difference is the difference of the integrals. So whether you physically wrote this or not, this is what I saw groups doing. You were taking the integral of 1 over x dx, and you're subtracting the integral of x to the negative 4th dx. Now, whether we physically write this or not doesn't matter to me, just so you know. Like, we need to know that it exists, and there might be situations where we do have to write it like this. This is a nice, easy situation. But realistically, we could probably just do it without this line. But I want to make sure that property is clear. Okay, now we get into the fun stuff. What is the issue with integrating 1 over x? If we try to use the power rule for this, and I'm just going to do this off to the side, if we try to do the integral of x to the negative 1 dx, we would add 1, so we get x to the 0, and we would divide by what? 0. But what can't we ever do? Can't do this. So that should be our catch that this isn't right. Now, you're going to get there pretty quick. Is there something that has a derivative of 1 over x? It's the natural log. So what's the antiderivative or the integral of 1 over x then? It's the natural log. This integral, and this is a rule, this is natural log right here. I'm trying to recall, somebody with your book open, is it the absolute value of x or is it just x? Is it abs val for the integral also? Okay. Thank you. Minus, and then let's do this one. I'm going to work this one out a little bit more detailed here. X to the negative 4, what would that become? And I actually don't think I really need super detail. What do we do with the exponent? What's negative 4 plus 1? And then we divide by this new number. And last little thing, I could have done plus c and plus c, but it's just plus c in the end anyway, so I'm just going to tack it on here. This bugs me. We have a correct answer in front of us right now, just so you know. But it really bothers me. Yeah, this negative winds up downstairs, but it doesn't really matter where it is. I see minus a negative, so we're just going to go one more line rather than just writing it here. This is a natural log of x plus, we have a choice. Do you want me to keep it x to the negative 3 over 3, or do you want me to make it 1 over 3x cubed? Okay. If somebody didn't want to do this and they just wanted to keep it with the negative, is that okay? I'm okay with it. Be prepared, like if this was a multiple choice, don't know if they'd have the negative or the fraction. Probably the fraction is my guess, but change it back and it's going to be easier to start recognizing these. Okay. Anything that we've done today so far feel brand new? The indefinite part, probably a little bit, but the actual integrating, does it feel any different than what we've been doing? Easier or harder than doing it with the bounds? I'd say it's easier. It's the exact same process, just with 2 less steps because you don't have to plug in the numbers. Okay, let's do some more of these, but let's get bigger with them. Now, for this, I'm going to let you guys do a little group work at your table. I'm going to give you 60 seconds, and I want you to try an integral for me. Okay, this one, be completely okay with, and I know it's an easier thing to say than do. I hope you're going to figure it out. Some of you might. I hope you do. We'll see. I'm going to give you a challenge. 60 seconds is what you get to try something. Okay, and I want to make sure that it's not unreasonably hard. The page I opened to just says more challenging, so that seems like it'd be a neat one to do. There we go. All right, so let's do one more. Oh, love it. All right. How gross do we want it? Okay, cool. So here we go. I want us to take the example, and it's a bit harder. So I'm just going to not even name it here. Let's see here. Love it. The integral of x squared plus 5, and that quantity is going to be cubed. But then we're also going to multiply this by something. We're going to multiply this by 2x dx. Now, here's the biggest part, and I see people writing, so I'm going to chill out a second before. You're not going to be able to do this integral. No offense. I don't think you are. But here's what you can do. Integration can be kind of tricky. The good news is we spent the first 5 months of this year doing not integration, but what was the other side of it? Differentiation. There's a connection between this and, I've already alluded to it, the chain rule that exists. If we can identify where the chain rule happens, we're going to be okay with this. Talk with your neighbors. Can you tell that a chain rule happened? That's the first question. So talk with your neighbors. How can you tell that a chain rule happened additionally? What do you guys think? No, you're okay. Love the idea, just so you know. Can you guys tell that a chain rule happened here? How? So the parentheses certainly help with the cube. And then beyond that, as I'm looking at it, what I see is if you were to think about this as a function, just x squared plus 5, and you took the derivative, the chain would be the 2x that comes out, right? And that's what did come out. So there is a chain rule happening here, and I can see it because the derivatives match up. Now, how we actually make this integral work is going to be the big part here, and it's going to be so much nicer than you expect. Questions if you have them, though. And that's everybody, just so you know. Clear chain rule? Why? And then if we were to differentiate it, what would, when we took the derivative of the inside, what would it spit out at us? 2x, which is the goal we're here. Okay. All right. So we are going to unchain this is what's going to happen. We call this U substitution. Now, we're going to do one together first, and then we'll go one of two routes based on your guys' feedback, okay? So honest feedback is what we need. I will certainly get you, like, here's a series of steps, but it'd be way better if you guys can come up with a nice series of steps as well if we do one or two and we just try to figure it out. So let's look at this integral together. First question, how do I know it's changed?